still recording
It is now recording. All right, so this is our Zoom lesson. We are on our new unit. That's why we have a new packet. You'll notice that this unit is exactly the same length as our old unit. Unit 7 was 12 days. Unit 8 is also 12 days. We have 3 quizzes, 1 test. It's going to be very, very similar. And let's jump right into it. Today's date is the 7th of March, 2023. We're on naming polynomials. By the end of this lesson, I'm hoping that I can write a polynomial up on the board and you will be able to describe it by saying, ah, yeah, that's a cubic binomial. By the end of today, that's what you'll be able to do. All right, so let's first talk about degree. Degree it has many meanings. It can be the number of degrees in a rotation, like how many degrees in a circle. But the way that I use degree in this sense is degree is the highest power of a polynomial. So I can write that in words. Highest power. You don't have to say in a polynomial. This whole unit is polynomial. So I'm just going to say highest power. So, for example, if I wrote something like 3x squared plus 9x plus 8x cubed.
Charlie?
Is him? Is he there? Hey, there he is.
I could only join for a little bit though.
So you can join for the whole class. Okay, cool.
No.
All right. Well, we have this this lesson recorded. So if you want to just watch the recording on YouTube later on your own time, you can do that.
Okay.
All right.
Thank you. Bye.
Bye. All right. So the exponent, or again, power, you can rewrite that as exponent. That's probably what I should be using. Exponent. You can say power exponent, but I'm using this word degree. Degree, exponent, power, they're all synonyms for one another. So that's a power. That invisible thing is a power, and that's a power. What's this invisible power again?
1.
All right. So what's the highest one?
8x.
So 8 is the coefficient. What is the highest power? The highest exponent?
3.
You can all circle in your notes. Yes, it's 3. That was the highest power. And the way that I say that this thing is degree 3. This entire polynomial is degree 3. Is that easy? Pretty straightforward.
Oh, so the polynomial is just degree and then the highest exponent?
Yeah.
Huh?
So this is a degree 3 polynomial. If I took that term away, what would the degree be then?
For 2.
Degree 2 polynomial?
That's the next highest one. So it would be a degree 2 polynomial. Yeah, I know, try something. It's okay.
I just like.
Okay, so that's the first definition I'm using today. The second definition is term. So a term is, I'm going to make it as simple as possible. Separate. Separate?
ER.
I don't know.
Oh, wait, no, it's 8.
Separate? Someone pull up their laptop. I need to know how to spell separate. Anyway, it's separated by plus or minus sign.
It is with an A.
Yeah. Feels good. All right. If you're separated by plus or minus, you are a term. So check this out. There's a plus right there, which creates an invisible force field. A plus right there, invisible force field. Guess how many segments? Guess how many terms we have?
3.
3. 1, 2, 3. So another way that I think of term is I kind of think of this as segment. Or part. Maybe you want to think of the word part. But the official word that we're using in math is a term. So this was a degree 3 polynomial with 3 terms.
What if it's a negative?
Great question. So let's do another example. If I did something like 2x to the power of 8 minus 2x to the power of 10. Let's put a negative out there as well. So how many terms are there now? 2. And what degree is that polynomial?
2 through degree 10.
Degree 10, because 10 was the highest power. So you can say that this one was degree 10 and 2 terms.
Okay, but Mr. Sindel, if you take that negative out from the first one, then when you separate it into two terms, is the term negative? Or is it?
Yeah, you can say that this entire polynomial, it doesn't matter if it's positive or negative. The terms are only affected by that thing is a term and that thing is a term. And it's depending on your definition. You can subtract a positive term or you can add the negative term. It doesn't matter if that term is negative or positive, depending on your interpretation. Yeah, I think that's your question is like, is it technically negative or positive? It's your interpretation. Okay, vocabulary is out of the way. Let's move into the new, well, that was new stuff. Let's move into the real content of today, which is this, names. All right, so when I want to name my polynomials, I name them by degree and by the number of terms. So I'm going to make a table here. I'm going to say degree, and then I'm going to say if it's a degree 0, a degree 1, a degree 2, a degree 3, degree 4, and degree 5, and then I'm going to put the name of it, and then I'm going to do an example of it. And then I'm going to do another table down here, number of terms. I'm only going to do out through 3, but I'll do for 4 just in case you want to see that. I'm not going to put that on a quiz or test. So I'll do, you need to have 1 terms, 2 terms, 3 terms, 4 and up. So I'll say 4 plus 4 and up is all going to be the same thing. So the number of terms, we need to name it, and we need to give an example. Ready, set, degree 0. I'm going to start with an example. 7. 7 is the degree 0, and here's why. This is technically 7x to the power of 0. Anything to the power of 0, you guys will all shout out is 1. Yes. So x to the power of 0, this whole thing goes away, and it's just 7. So if I just have numbers, those are degree 0 terms. Let me give you another example. 2. That's a degree 0 term, right? All right. The name of this one is constant. And we've heard that term before. It just means it doesn't change. There is no variable. Variables allow it to vary and change. If it doesn't change, it's constant. So 7 is constantly 7. It doesn't change from 7. All right, 1. An example of this would be like 7x. Because technically this x is to the power of 1. And that's called linear. Linear. We've been studying those functions. We studied the functions like y equals 2x plus 7. Well, this was 2x to the power of 1. This was a linear polynomial. It was linear because this was x to the power of 1. What happens if we go higher? What happens if I do like 23x to the power of 2? Notice the powers went 0, 1, 2. This one has a new name. It's going to be quadratic, which is usually the most confusing one to students because you see the word quad and you think, oh, that's 4.
No.
So the reason that these are called quadratics is a little bit strange, but they came from rectangles. If you divide a rectangle up and then you multiply x and minus 2 and x and minus 2, what happens on the inside is you get an x squared term. So this rectangle or this quadratic function, this is a rectangle function. That's where the root word comes from. So sorry that it's confusing. That's how math operates right now. All right, the next power will be a power of
3.
that is the power, right? Degree and power mean the same thing. They're synonymous. Yeah, exactly. Cube. So give me a cubic. Give me something cubed.
14 x cubed.
Next cube. There it is. This is called cubics. Which makes sense. You cube it, therefore it is cubic.
Wait, but why wouldn't? Never mind.
Okay. Someone give me an x to the power of that degree term. We'll just say, yeah, x to the power. You don't even have to have a coefficient. Boom, done. X to the power 4 is an example. That is called quartic. Not with a Q. I think it's a C. Quartic. Quartic. Is it with a Q? I think it's with a Q. Quartic. I'm gonna guess it's with a Q. Grace, fact check me. Type in quartic and see if it comes up with anything on Google search. I always say these things out loud. I don't normally write them down. Quartic.
Yes, with you.
Yes, got it.
It's gonna smell.
Aaron, give me another something example.
X.
There it is. 23x to the power of 5. You stole my 23. My coefficient
Sorry.
already had that.
Then change it to 25.
Okay.
30.
And finally, this is called quintic.
40 quintic.
Yeah, so there's a lot of names to memorize there, and you're going to be using these over and over today. Constant, linear, quadratic, cubic, quartic, quintic. That's half the puzzle, the degree of the polynomial. The second half of the puzzle is the number of terms in that polynomial. So if I have one chunk, one segment, one piece, that means I have one term. So for example, I could do like 3x. There's one chunk there. If I want to add on a second chunk down here, I can say 3x plus 2. Now there's two chunks here. So if I have one chunk, one term, that's called monomial.
Oh, like mono.
Exactly. The word mono usually means
Binomial?
one. Oh, she got it. The
Oh,
2 one
yeah.
is bi, because bi means 2. Binomial. And if you're riding a bicycle, it has 2 wheels. Oh, you know, if you have a 3-wheel bike, it's called a tricycle. So this is not a binomial, it's a. Yes, right. Exactly. Good job, guys. Trinomial. So an example of that would be something like 4x squared plus 2x minus 7. There's 1, 2, 3 terms. And those are the ones sorry, I know it's getting low in the word. I don't even know, can Lynn still see this?
Is Charlie even still there?
He left.
He
Get over a little bit.
And then he left.
Yeah.
Really? I didn't think he left right away.
He said hello, goodbye, yeah.
Yeah, what's with that?
I don't know.
He's home.
So if you have 4 more terms, you just say 4 terms.
Okay, I didn't know how to say it.
Or guess if there's 27 terms, you say 27 terms. It's very uncreative. So I'm not going to do an example down there. You can kind of figure it out. All right, so we're going to put all those pieces together. I'll do one final example. Can I squeeze it in down here? It just means straight go to underneath this table. On the very next line, we'll do one example that you might see on a blueprint. Call this example 1.
Oh, I forgot to play.
Example 1. Name by degree and number of terms. That's always, I can spell it. That's always my instructions, and I'll give you some polynomial like this one. 2x minus 19x to the power 4. All right. We always have 2 names 100% of the time. You always have 2 names. One from that table, one from that table. You start with the degree. So which of these words is going to be used to describe this polynomial? Sorry.
Quartic.
It's going to be quartic because look, the biggest number, there's a number of 1, there's a number of 4. The bigger one is 4. So you come over your table, quartic, you write down your answer. This is a quartic.
Binomial.
And then you say, okay, how many chunks are there? There's 2 chunks.
So
2 chunks.
Quartic
Binomial.
binomial.
This is a quartic binomial.
This actually is this first.
Oh, that's easy.
Oh.
Done. You're gonna do that over and over and over again, which is weird because I'll give you a number like 5. You'd be like, that's 5. No, this is a constant monomial. All right, it's gonna be a little bit tricky.
I'm not trying to say these fast. I'm just like, ugh.
All right, that's all we have for the recording. Let's see the quick fist of 5. How well do you think that you can start naming these things? You'll memorize the table. If you had a table, we'll assume you have that memorized. If you have the tables memorized, how well could you do this on a fist of 5? 4, 4.5, 4.5, 5, 4.5, 5, and Lynn is at a 4. All right, so I'm gonna go ahead and stop the recording. Stop.